Hello everyone, good evening. Ah, what a month it has been, hey? There we go. I'm going to set that sky to start slowly moving so we can see some things. So hello everyone, my name is Mitchell from Wollongong City Libraries and welcome to Starstruck for August. So we'll be looking at what we can see in the sky tonight and also what will be going on sort of in the month coming up, different astronomical phenomenon, things that are worth sort of looking at in the sky. So what we're seeing right now is just today. We're just watching the sun go through the sky today. I can see Clancy in the chat. Hi Clancy. Feel free to say hi guys. Hi Trish, great to see you. Fantastic. And of course, soon enough, you can probably tell we're about to see our sunset here on the screen. I can see I do have a little bit of lag here at my end, but that's all right. I might be a little bit slow responding to some of your comments, but I will get to them when I see them. Here we go. And now we're getting to nighttime. A much clearer sky in our digital planetarium this evening than we've got outside. Here we go. So I'll bring us through to now. So these are the stars that are in Wollongong's sky right now. Obviously tonight it's much cloudier, much harder to see, and also of course usually here in the big city we've got a lot of light pollution. So you might be used to the stars looking a little bit more like maybe like this where you're from. If you look outside in the evening, this might be more the sort of thing that you're used to seeing, just a couple of stars speckled around. But that's one of the wonders of the digital planetarium. We can actually get rid of all of that light pollution. Here we go. And we'll see those beautiful stars that are out there. So of course, there is a lot happening in the sky this evening. One of the first things you'll probably see here, and one of the things we didn't actually talk about last time, is stretching right across the sky here. We have this beautiful, colourful shape here, which of course is the Milky Way. And it's called the Milky Way because a long time ago, when people were first sort of looking up at the sky, they thought that looked a little bit like someone had sort of spilt milk across the sky. Of course, we know now that's not how that works at all, and no one's been spilling milk in the sky. The Milky Way is actually the galaxy that we live in. So there are millions, billions, uncountable numbers of stars up there in space. And most of the ones that we can see from here on Earth are actually inside the Milky Way galaxy. I will actually, if we just sort of put the Milky Way up like this for a second, I want to talk about sort of what that looks like. Because especially in this area and all around Australia, a lot of different Aboriginal groups have different the way we talk about constellations and we talk about certain shapes and certain stories related to the sky, they've got their own stories and their own shapes to tell. And one of the ones that's, very easy for us to see is the emu in the sky. And that's actually an interpretation of the Milky Way. So if we look here, we can sort of see this sort of central part of the Milky Way here. That's sort of like the feathers of the emu, the body of it. It's got its legs down here. It's a beautiful night to see it tonight, actually. And then reaching up the top here, we've got that long neck and this sort of dark spot just underneath the Southern Cross here, we've got the beak of the emu. So that's our emu in the sky. And you can see, in Western astronomy, we tend to define our constellations by stars and by bright objects in the sky. A lot of other cultures will actually define it by the darkness and the shadows in the sky and the dusting in the Milky Way. So we've got this big, beautiful galaxy in front of us here. And like I said, most of the stars we can see are actually in that Milky Way galaxy. And so are we. So the same way the moon goes around the Earth and the Earth goes around the sun, The sun actually goes around something called a supermassive black hole. And the supermassive black hole is pretty easy to find. It's bang in the middle of our galaxy. And most of the stars we can see are going around and around and around that galaxy with us. So there's a lot of things we can see pretty much every night. And tonight is no different, except for the clouds. So we've got our wonderful galaxy up here. But of course, stars aren't the only thing that we've got in the sky. We've also got, of course, lots and lots of planets. If you watched last month's Starstruck for July, you'd know that we've just seen the opposition of Saturn and Jupiter very recently. So opposition is when, oh, we just had a shooting star. I don't know if you guys saw that. So opposition is when the Earth and another planet are as close as they're going to get for the entire year. So for all of Earth's like big circle around the sun for that year, that's the closest point to that planet that year. And we've just had that for Saturn and Jupiter. So they're both still very bright in the sky. I'll show you so you can tell where we're looking. I'm just going to put up some directions here, east, south. Here we go. For us to find planets, it's easiest for us to look vaguely northwards. Just because the same way we have the Milky Way sort of looks flat because it's sort of like a big disc shape. And we're right on the edge of the disc looking inwards and sort of seeing that flat shape. It's the same with our solar system. So all of our planets, the sun, the moon, everything in our solar system sort of goes along this same flat kind of line here. So if I put that line up, you can probably actually identify a couple of planets yourselves just by looking along that line and seeing what's really bright. Oh, Elaine is saying you can see a few stars tonight and the clouds are disappearing. That is fantastic. When I was looking out earlier, I sort of poked my head out and I couldn't see anything. So it's really good to know that it's starting to clear up, and hopefully you guys will be able to get out tonight and see if you can see some of these things. So yeah, along this line, which we call the ecliptic, we can actually see everything in our solar system happens on this line. So I believe this little bright thing here, that looks like Mercury to me. Yep, so that's a planet Mercury. And Mercury is actually going to be at its elongation on the 14th of September. So elongation, yes, Trish has found, so we do have Jupiter. Venus is actually over here. So Venus and Mercury have this strange sort of thing called an elongation. An elongation happens when, well, it's sort of like, because they're closer to the sun than us, it doesn't look like they go around us like most of the other planets do. We actually sort of see them just kind of going back and forth. So elongation is when they're at their furthest point on one side before they start to go back. So because we've just had the sun set in the west, we're always going to have Mercury and Venus. If we see them in the night, they'll be in the west part of the sky. So here's Mercury, and in about 2-3 weeks, it's actually going to be the furthest, the highest in the sky it's going to be. So it's a great time to be looking out for Mercury. Right after the sun goes down, it'll be pretty easy to find. We might actually jump ahead later on and we'll look at what the sky will look like that night. So it'll be easier for us to find. Let's actually have a quick look at Mercury. Let's zoom right on in there. There we go. So Mercury is the closest planet to the sun in our solar system, and it's also the smallest. So there are a lot of moons out there in our solar system that are bigger than Mercury. Yeah, Mercury's a pretty small, celestial object, to be honest. Even though it's the closest planet to the sun, it's not actually the hottest because it's got very little atmosphere, so very little ability to actually retain heat. So a planet like Venus that has a lot of carbon dioxide is actually going to be much hotter. So here we've got Mercury, not quite at its elongation tonight, but getting there, very close in terms of, what we see in a year. Okay. Mercury is actually, it's worth noting, one of the few planets with ice on it. Well, actually a lot of planets have some kind of ice, but there are very few things that we know of in the galaxy that have ice, like frozen water. So Mercury does have polar ice caps, the same as Mars, and the same of a couple of Jupiter's moons and one of Saturn's moons as well, which is pretty important if we were to, start looking at space travel and landing and inhabiting other planets. It's good to know we've got a potential source of water on Mercury already. So we'll leave Mercury now, and then we'll just travel up that ecliptic a little bit more, and then we will get to that very, very bright one there. Here we go. So like we said last time, Venus is the brightest thing we will see in the sky other than the sun or the moon. So anything that looks like a star, sort of small, bright, shining object, the brighter it is, the more likely it is to be Venus. And right now, in the west sky, right after the sun's gone down, it's a perfect time to be seeing it. So this is Venus, our hottest planet in the solar system right here. Yeah, so it's second from the sun, but again, incredibly, incredibly, incredibly hot. So you can take a frozen pizza outside on Venus and have it cooked to perfection in a number of, short minutes, and then burnt to a crisp right afterwards. It is absolutely the hottest planet on our solar system, and again, that's all because of that carbon dioxide holding in all that heat from the sun. And I just want to move on pretty quickly from there, because we did talk about Venus a fair bit last time. And like I was saying, we've just had, I've gone out very far. We've just had the opposition of Saturn and Jupiter. So Trish, when you called out, Venus and Jupiter on the west side. I read east for some reason. Yeah, so we've got Venus and Mercury over there on the on the west. I'm getting myself confused now. And we've got Saturn and Jupiter over here in the east. So rising this evening, very nice and bright. If we just keep going along this ecliptic, here we go, will be Saturn. So of course we looked at those beautiful icy rings in quite a lot of detail last time. And like I said before, one of Saturn's moons does have some water on it, which I think is sort of worth looking at and exploring a bit. So that is Saturn's moon Enceladus. So I'm just going to turn on some labels, because honestly all these moons look the same to me without them. Here we go. We can't get too close to these. As close as we can, that's about it. But that's Enceladus, one of Saturn's moons, I believe the second one to be found. And Enceladus is very, very special. One of 3 moons in our solar system to have water on it. Not in terms of a liquid, but frozen ice at its caps. So same thing, if we zoom out a little bit from Saturn, we'll go along that ecliptic a little bit more, down, 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 and here we go, we'll find Jupiter. And here on Jupiter, around Jupiter, we've got 2 other moons with water. So we've got Europa is actually in front of Jupiter here. That's quite a nice view actually. So we can see Europa and also the shadow of Europa on Jupiter this evening, if you've got a very good telescope and get it at exactly the right time. So Europa is actually a candidate for liquid water and actually having an ocean underneath the surface of the planet, which is incredibly exciting and actually one of the best candidates in terms of potentially going and inhabiting an extraterrestrial body in our solar system. Sort of Europa and Mars were the two candidates that have been looked at the most commonly and the most closely. So it's pretty exciting to have Europa there. And of course Ganymede as well. I think Ganymede might actually be behind Jupiter. So I'm just going to zip forward in time a little bit, and we'll just watch Jupiter rotate there, and we'll see if we can get Ganymede to rotate out the other side. So we've gone through to about 10 o'clock tonight now, and there's Ganymede. Ooh. It's having a little bit of trouble showing us Ganymede, but you can see there a very big moon, also with potential ice and polar ice caps on that moon. So a lot of candidates for water in our solar system. We've got Earth, of course, the other planets Mercury and Mars. We've got the moons Enceladus, Europa, and Ganymede. And we've also got two of the dwarf planets as well, which is Pluto and Ceres. Both have potential water on them. And then, of course, we've also got Neptune and Uranus, or just sometimes called the ice giants, because they've got ice sort of mixed up in all the gas in them as well. So those are the planets we can sort of see tonight. Very easy to find, just going along that ecliptic. You can see we've got the moon there has started to come up because we've gone through to about 10:30. I might actually go back to Jupiter quickly. Ooh, there's Ganymede. And we'll take us back to where we were in terms of time. We'll just zip backwards quickly. There we go. That's about 7 o'clock. That's pretty close. Because I want to point out that beautiful great red spot there, which we did talk about last time, but we weren't quite able to find. And here it is now, a great shot of the great red spot, which is also very important for the last planet we're going to look at tonight, which is going to be Neptune. So on the 14th of September, the same time we've got the elongation of Mercury, we're actually going to have the opposition of Neptune. So the closest, biggest, brightest Neptune is going to be in our sky. And that's pretty important because Neptune is actually incredibly difficult to see. It's actually in our sky in this digital planetarium right now. But, you can tell even with our labels on, it's actually not big enough for us to see. So what I'm going to do, let's change our time. We'll go through, so we're jumping through a couple of days, and you can see as we change days and go forward in time how the sky we're seeing sort of changes with the season as well. The beautiful full moon is sort of brightening things up a bit there. And we'll take it a little bit earlier as well. There we go. So we're just on sunset on the 14th of September now. And you can see the sun's gone down, Venus will come up. Venus will be the first thing we see that evening. Very bright, very easy to identify in the western sky. And sort of, so at this time, 6:15, between Venus and where we see the sun goes down, you'll be able to see Mercury as well. So this is as high as Mercury really gets in the sky right now. So a very worthwhile time to be watching and a very worthwhile time to be keeping our eye on the sky. You might see that bright star there. I don't quite know, if we turn up our light pollution, you can see it, you can still see it a little bit. That's Spica, which is one of the brightest stars in the Virgo constellation. If there are any Virgos who wanted to see, that's a great time to look. So 14th of September, Venus and Mercury, there they are. And then we'll sort of zoom out a little bit and let's just watch this sunset and the stars come out. Here we go. So we will have a very bright moon that night. I think it should be about a 3/4 moon. So we're coming up to a new moon in about a week or two on the 7th of September. So a new moon is when the moon is reflecting no light from the sun at us. So we basically won't see the moon at all. And then on the 20th of September is when we'll have our next full moon. So what we're looking at right now is the 14th. So we're still a week before the full moon. So it won't quite be super bright. Here we go. So we're coming through to around sort of 7 o'clock now. We'll go a little bit faster. Because remember, what we're looking for is Neptune at opposition. Opposition means it's as close to us as it gets, but Neptune is further away from the sun than us. So for us to be looking as directly at Neptune as we can, that's going to be in the middle of the night. So I've come through to midnight. All right, and let's see if we can find Neptune now. So looking at our ecliptic, I'm just going to make that as flat as we can. I can see the moon very bright. I can still see Saturn and Jupiter will still be hanging around. I can even see Uranus over there. Neptune is very, very difficult to see. But we know it's at opposition. We know it's going to be along that ecliptic line because everything in our solar system is along that line. and we know we're looking as directly at it as we can. So if we zoom right in here in the middle of this line, here we go, and I can see the label has started to pop up here. So there is Neptune. Let's zoom right in there. Here we go. And I can see I've got a little bit of sort of shaky there. I'm just going to rotate it around and see if we can get a better view. Whoop, too far. I've gone into the next morning, which is why we got the bright sky sort of getting in our way there. But if I just take Neptune around, there we go. That's a beautiful view. So the same way before, we were talking about Jupiter having a great red spot. And last time we were saying that that's a storm that's been raging on Jupiter for quite some time, for hundreds of years in fact. Neptune actually has something called a great dark spot, which you can see right here. And it's the same sort of thing. That's a really big storm that's raging on Neptune. Now the storms on Neptune don't last quite as long as the ones on Jupiter, which are, hundreds of years. So the Great Dark Spot was first seen, I think it was in 1989. And that lasted a couple of years, then it seemed to disappear. The one we're seeing here, we just keep calling it the Great Dark Spot, whichever the biggest, darkest storm is on Neptune at the time. This one's been going since about 2016, so about 5 years. We've had this beautiful Great Dark Spot. Now, that's a very difficult thing for astronomers to find, because as you might have noticed, Neptune itself is a very difficult thing for astronomers to find. And it wasn't actually found by accident or by telescope or by getting really lucky. It's actually the only planet in our solar system that was found entirely by maths, which is one of my favorite science stories. So way back in the 1800s, a lot of work had been put into figuring out how our solar system works. We'd had astronomers like Copernicus, Galileo, Kepler making leaps and bounds into figuring out, that planets go around the sun, the way it all worked, figuring out, the force of gravity, how fast things are moving. Really great work there. But when they were looking at the orbit of Uranus, something just wasn't adding up. And they couldn't figure out what that was. They were questioning if maybe, from a far enough distance, maybe gravity just doesn't work the way we're used to it working. But the motion of Uranus inspired scientists. And they sort of proposed this idea that perhaps there was something else in our solar system that was really, really big and really, really far away, right on the edge of our solar system out there. And they didn't know what exactly they were looking for. But when they, eventually they got good enough telescopes, they said, okay, this is where this thing should be. This is where this large, heavy planet should be. And before we even saw Neptune, we knew roughly how big it was, roughly how heavy it was, roughly how far from the sun it was. We had all this information about it. We just didn't have technology like telescopes good enough to see it. And eventually we were able to find this wonderful last 8th planet of our solar system, hiding out on the very fringes of our solar system there. And it's all because of that maths that was put in. And I just think that's a beautiful story of, this sort of thing took decades, hundreds of years to sort of get from a point of, hang on, the planets we can see aren't behaving the way we think they should. And then going from there to figuring out, oh, that's because we've got this other thing going on here. So there's a lot of really exciting things coming up. We've got, this is that same night, the 14th of September. We've got Neptune at opposition, very nice and high in the sky. We've got Mercury at its elongation, so as high in the sky as it's going to be. And then later on in September, on the 22nd, we're going to have something called the September equinox. I'm just going to zoom out a little bit. I'll turn that line off. And we might just get this spinning a little bit so we can see the movement of the stars as we talk. So the September equinox is coming up. We have 2 equinoxes each year, so one in spring and one in autumn. And the equinox is basically when the seasons change over. So the equinox is unique for being, the 2 days of the year where basically almost all of planet Earth has the same amount of daytime as it has nighttime. So in the 24-hour day, we'll have 12 hours of sunlight and 12 hours of darkness. So because Earth is sort of at a little bit of a tilt on its axis, sometimes, here, if we're here in Australia, sometimes we'll be tilted towards the sun. That's when we get summer, we get a lot more daylight, we get a lot more heat. Sometimes we'll be tilted away from the sun. And when that happens, we sort of get winter, we get darkness, less daylight hours. But for those 2 days a year, we'll actually have 12 hours of sun and 12 hours of darkness, and that is the equinox. So our equinox is going to be happening on the 22nd of September. So sort of between now and our next Starstruck, keep an eye on the sky, keep an eye on the hours of the days, because they're going to get longer and longer and longer. And very soon we'll be sort of coming out of winter, thank goodness, and we'll be entering into that time of the year when we've got more and more sunlight, more warmth, and more time to just sort of enjoy ourselves in the day, which is very nice. And fingers crossed, fingers crossed lockdown will be kind to us, but we'll see what happens. All right. So we can sort of see Uranus coming up in the sky there as well now. We might as well take a cheeky peek at that. So let's zoom in here. And I'll pause our stars from moving so they don't get away from us. Here we go. And here's Uranus. So we've seen all 4 of the gas giants across these different nights we've looked at. So this is still the 14th of December we're looking at. Sorry, not December, September. The 14th of September we're looking at right now. We're a bit later in the night at 20 past 10. And we've got, you can see Uranus here. You can see the rings around Uranus. You can see a lot of Uranus's moons here. As far as, as far as planets go, Uranus looks kind of plain, very pale and featureless. It is a gas giant, just like Saturn, Jupiter, and Neptune. And honestly, it's kind of unremarkable. There's not really much to see there. However, it is a sort of hotspot for more probes that we're sending out, further beyond the sort of the planets closer to us. As we're sending more and more things further out into space, Uranus is getting a little bit more attention than it's used to. Okay. For now though, guys, I think we might as well, I'll zoom right back out, and we might as well watch a quick sunrise. And I'm on a couple of seconds delay, but if anyone's got any questions about anything, now is a great opportunity to ask. We've got a little bit of time left now at the end to see if there's anything else that anyone wants to know, anything anyone wants to see. Now's a great time for us to sort of explore the skies. And I'll just let that come through to daytime. We're at about 2-3 o'clock in the morning now, so that won't be too much longer. And then we'll just go back and we'll sort of look over what's in the sky tonight. So if those clouds do clear up, or maybe even tomorrow will be very similar, we'll have a good idea of what we're looking for and where it'll be. Beautiful, there's our sunrise. So let's stop that there and we'll head on back to today, the 26th of August. Beautiful. And I'll close that. We'll get the sun going through the sky. And let's get a nice little sunset. There we go. So again, this is tonight we're watching now. We can see it getting darker. Venus, of course, the first thing we see. Mercury as well. Might be still a little bit low. Those mountains that we've got to the west of us here in Wollongong make it really difficult to see Mercury. but it will still be up there in the sky, as well as Saturn and Jupiter in the east, making it much, much easier to see. And then as we sort of spin through, we've come through to about 8 o'clock now. And you can see a lot of those constellations we spoke about last time. We've got the Southern Cross over here in the southwest of the sky at a little bit of an angle. And we've also got Scorpius, is quite high in the sky at the moment. So very easy to find with that bright star Antares in the heart of it, sort of going 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, to sort of join those stars up and make that shape. Oh, do we know how hot Venus gets? And do you think anything can survive on it? We do know how hot Venus gets. I can't recall the exact number off the top of my head. I believe it's something like 600 degrees Celsius, or it could be close to 800. I'm pretty sure it's like an even number like that. In terms of anything surviving there, not the kind of life that we're used to, but that doesn't mean nothing at all. So even on Earth, we see a lot of creatures and a lot of life that sort of adapts to different niches and different kind of specialty environments. So we see things, adapt to the freezing cold. We see things adapt to living in, volcanic vents under the ocean that love really hot environments. So it's not necessarily out of the question that something would be able to survive there. A great example, we've got a creature here on Earth called a tardigrade, or more commonly known as a water bear, and they are basically indestructible. They can survive the vacuum of space. They usually just live in the moss, like moss you might find in your gutters, and they're used to sort of drying out for years at a time, getting a little bit of water, then just sort of regenerating back to life. Incredibly hardy creatures. So it's not even out of the question that some of the life we have here on Earth could actually thrive on Mars or Venus. Do we know how heavy the moon is? Again, I personally don't, but it's definitely something that we can calculate. So we know that that the moon, if we sort of like flattened it out, when you get like a mandarin and an orange and you peel the skin off it, if you flatten that out, the moon's going to be, roughly the size of Australia. So then we can sort of figure out from that, okay, so that's the size of the moon. We know what it's made of. We've sent rovers and stuff up there. We've got the rocky samples. We see the speed that it goes around. So we do have a really good estimation of how heavy the moon is. In fact, I might even be able to, if I click on my moon here, I might actually be able to get the information out of this program, if we're lucky. I'm not seeing mass on here. If anyone else can see mass, let me know. But additional information, that could be it. I'm not seeing it, unfortunately. That's something I'd have to look up. But that's not a problem, because if a lot of the time we do have questions like that, things we're not sure about, things that we want to learn more about. And we're actually very lucky because if we do need information like that, like we've got our library services, which is where you're watching this. So I presume you guys are library members. And if you were to head to like the library website or something, let's go, if we go up here to learn, we can go to online research. And I'm actually going to use our database called Gale, which is our online research platform. And a really good tool. So I'm going to scroll on down here. I'm going to go straight to, let's go to National Geographic. That seems like the sort of thing that would know. And I'm just going to search National Geographic for moon. And we'll see what comes up. A lot of things come up for the moon. That's not surprising. So if we spend a bit of time, we could probably figure out what the mass is of the moon, using these resources we've got on the library website, using National Geographic, using some of our ebook platforms to find books on space, or services like Canopy and Hoopla have documentaries and videos as well, if you want to sit down with the family and watch some space videos. Speaking of which, guys, I have gone a little bit over time. Thank you so much for your questions and your interest and for tuning in. And next time I'll see you will be September, and we'll be looking at how the sky has changed from now until then. And hopefully, you know, life will have changed a little bit between now and then as well, and we'll see how that goes. For now, though, thank you so much again for tuning in, and I will see you all next time.